to show you an example of how to prove a trigonometric identity. The goal is to prove that the left-hand side and the right-hand side are exactly equal. Now, this is not like solving an equation. We're not going to solve this equation to figure out what the value of x is. In fact, in an identity, this equation is true no matter what the input value is. Okay, so the first thing you have to do is decide which side you're going to start with. So we start with one side and we don't look at the other side for a while. Often I say, let's start with the most complicated side because that gives us more stuff to work with. So I'm going to start with the left-hand side. So I'll just write that down. I'm starting with the left-hand side. Now, how am I going to get from the cotangent of x over the cosecant of x? How am I going to manipulate that to get something that is the cosine of x? Well, I'm going to start by looking at identities and seeing if there's something I can substitute in for that cotangent and cosecant that will get me closer to my goal. So I'm going to substitute using quotient and reciprocal identities, and I remember that the cotangent of x is actually the cosine of x over the sine of x, and the cosecant of x is 1 over the sine of x. Now, one thing that I'll mention is that one way to start these things often is to try to just rewrite everything in terms of cosines and sines. Now, that doesn't always work, but it's a good thing to look at when you're first starting. So I'm going to do the substitution, and in the numerator I've replaced the cotangent with cosine over sine, and in the denominator I've replaced the cosecant with 1 over the sine of x. Now I'm going to go ahead and simplify that and then figure out what my next move will be. So this is a complex fraction where I'm dividing. So I'm going to simplify by dividing the fractions. So the cosine of x over the sine of x divided by 1 over the sine of x is equal to, if you remember fractions, when you're dividing fractions, you're actually going to multiply by the reciprocal of the denominator. So we have cosine of x over sine of x times the sine of x over 1. And I'll go ahead and try to simplify that, and I can see that the sine and the denominator will cancel out the sine in the numerator. And so after I've done that simplification, I am simply left with cosine of x, which happens to be my right-hand side. So I have proved that the left-hand side is equal to the right-hand side.